Good morning to one and all present here. I am Dr. K. Kannan, Assistant Professor, Department of Computer Science, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. Today we are discuss about and understanding transaction management. This is for agenda and understanding transaction management. First we discuss about the introduction to transaction and ACID properties and transaction, and introduction to schedules and serial schedules and non-serial schedules and conflict serializability and view serializability and procedures graphs and recoverable schedules and cascadeless schedules. So first we are discuss about what is the understanding transaction management, the challenges in transaction schedule, and so conclusion. The first of all we discuss about the introduction of transaction. The transaction definition: a transaction consists of a series of operations they executed together, ensuring the logical coherence in databases. The next one is data integrity assurance. The transactions are vital for maintaining data integrity, preventing the partial updates during concurrent operation scenarios. And the third one is consistency maintenance. By grouping operation transaction help the ensuring the database the remain in a considered state after changes. The next one is what is the ACID properties and transaction. First of all, what is the discussion about what is the atomicity? The atomicity guarantees that all operations in transaction are completed or none at all. Next one is isolation. The isolation ensures that transaction execute independently, preventing the interference from concurrent execution. Next one is the durability. The durability guarantees the permanent effects of committed transaction, ensuring the data survival the post crash or failure. The next one is what is the introduction to schedules. The definition of schedules. The schedules defines the order of transaction operations, the crucial for managing concurrently in database system. Next one is role in concurrency management. The effective scheduling ensures proper concurrent transaction execution is while preserving data integrity and consistency. And the type of schedules, two primary type exist. One is serial schedules, which are sequential, and non-serial serial schedules allowing the overlaps. First we are discuss about serial schedules. The serial schedule definition it is a serial schedules execute the transaction sequentially and ensuring the no overlapping operations, thereby the maintaining the consistency and characteristics of the serial schedules. The key trails include the simplicity in execution order and the predictable state transaction and easier to error handling. The example of serial execution is considered to T1 and T2. The T1 complete before T2 starts. It demonstrates a valid serial schedule. Next one is non-serial schedules. The non-serial schedule definition. Non-serial schedules permit overlapping execution of transaction, the enhancing system performance through the concurrency and resource sharing. The benefits of non-serial scheduling: they improve the resource utilization and reduce the wait times for the transaction. They contribute significantly to system efficiently and throughput. The example of the concurrent execution in non-serial schedules is the transaction is T1 and T2 may both read and write concurrently. It is called as optimizing the operations. Next one is the conflict serializability. The conflict serializability is defined the ensure non-serial schedule are equal to serial one where operation is independence. The testing method is overview. The testing of conflict serializability can employ serialization graphs to identify the cycles indicating the conflicts. The next one is illustrative example. The considered transaction is T1 and T2. Their operation is demonstrate with conflicting access on shared data elements in uniquely. And view serializability. The view serializability definition is the guarantee of outcomes of transaction. The conform to some serial execution is sequence equivalently. Comparison with conflict serializability. Unlike the conflict serializability, the view serializability is the focus on the outcome rather than operation order is independence. Next one is characteristics of view serializability. It is accommodates the diverse of execution is order, the ensuring all operation in result equivalent to the serial transformation. The presence of graphs. The presence of graphs introduction is graphs is visualize the dependencies in schedules and facilitating the conflict serializability is testing and analyze the effectively. And the next one is constructing the graph. The create presence of graph. The identify the transaction and draw edges denoting the dependency and between the conflicting the operations. The next one is interpreting the graph result by cycling the presence graphs. They indicate the conflict serializability. The cycle is inserted of signify the conflicts preventing the serial equivalence among the schedule. The next one is recoverable of schedules. The recoverable of schedules enable the recovery without losing the committed transaction, ensuring the data consistency during the failures. The cascading the rollbacks of prevention to avoid the cascading the rollback and the strategies including the using the stick protocols and maintaining the dependency in tracking efficiently and impact on transaction efficiency and effective recoverable scheduling techniques enhance overall transaction efficiency while the safeguarding the against the integrity issues. Next one is cascadeless schedules. The cascadeless schedules they prevent the cascading rollback by ensuring one transaction does not read uncommitted data. And the significance of cascade schedules, the enhanced system reliability by preventing the rollback and the propagation across the different transaction during the failure. And an example of illustration, the consider the T1 commits before the T2 reads. This isolation is exemplifies the gasketless scheduling is strategies success. The challenges in transaction scheduling, the deadlocks, it is occur the transaction block each other, the creating a standstill, the halt system processing indefinitely, and starvation is erased the certain the transaction is or preferably and denied the resources due to prioritization of others, the impairing the execution and the performance overhead. The concurrency control the mechanism introduce the performance overhead impacting the throughout and response time during the transaction management. So conclusion, the role of effective scheduling. The effective scheduling is significantly enhances the transaction management by the preserving the data integrity and optimizing the system performance. Next one is impact on data integrity. The proper transaction scheduling is directly influence data integrity through the control the execution order and conflict resolution strategies. Next one is the system performance benefits. The advanced scheduling techniques facilitate the better resource allocation, ultimately the improving overall performance in the database system. Thank you.